So our group is from Precision Agriculture, and our focus was connecting the traditions associated within agricultural practices and the innovation that's currently happening. So I'm Sydney.
I'm Eliana.
I'm Virginia. Precision agriculture is the use of modern technology to make practice of agriculture more accurate and more controlled. This helps farmers to manage their land by utilizing a wide array of technologies and techniques to gather, process, and analyze data for the most efficient, productive, profitable, and sustainable agricultural practices.
Perfect. So before modern technology, Indigenous communities practiced precision agriculture based on their intimate knowledge of the land, local ecosystems, their natural cycles, and they developed sustainable agricultural systems that were finely attuned to these environments. So they observed the behavior of plants, animals, and natural phenomenon to understand the best times for planting. They adapted practices that maximized their yields and ensured sustainability. Many Indigenous cultures use companion planting techniques like the Three Sisters mentioned, which is where they planted different crops together to enhance productivity and provided mutual benefits. And they also use specific water management techniques to avoid nutrient depletion and control pests and diseases naturally. And overall, but this started to change more in the Industrial Revolution in the 18th and 19th century, where we were introduced to mechanicalization in agriculture with steam-powered machines later and tractors that transformed practices, making them more efficient and productive, as well as chemical inputs and eventually precision agriculture as we see today. So before we proceed with our presentation, due to the Indigenous origins of agriculture across the state and the nation and the ongoing discrimination and rewriting of deserved recognition, we would like to take a moment and acknowledge the land we stand on and the practices we speak about today. So we want to honor the legacy of Vermont's Indigenous people, the Abenaki people of the Dawn, who have cared for this land in generations and continue to do so. We recognize the colonialism and oppression of Native people as a current and ongoing process, and we commit to building our awareness of present participation. We pay our respects to the elders past and present, and we honor this with deep gratitude to the land and all it gives us. We also honor the histories of BIPOC people and acknowledge both the painful history of enslavement and that this country was built on the backs of Black and Brown people. In the words of Chief John Stevens in the Naugan tribe, please learn more about the Abenaki culture and history, support the Abenaki people, stay engaged, be kind and caring and accepting of the Abenaki people, and honor the fact that they have always had and continue to have a lot to offer.
Components of a PA system. Sensing technology. Precision agriculture relies heavily on the various sensing technologies to collect data about the farm and its environment. These sensors include GPS receivers, drones, satellites, weather stations, soil moisture sensors, yield monitors, and more. They gather essential information about soil conditions, crop health, weather patterns, and other relevant parameters. Data management and analysis. The data collected by the sensing technology needs to be managed and analyzed effectively to derive meaningful insights. This component involves the use of specialized software and algorithms that process the data, create maps, identify patterns, generate actionable information for farmers. Automated machinery and equipment. Precision agriculture often incorporates automated machinery and equipment to carry out farming operations with higher accuracy and efficiency. Decision support systems. DSS and precision agriculture assist farmers in making well-informed decisions. These systems combine data from various sources, such as sensor data, historical data, and agronomic knowledge, to provide recommendations for optimizing crop production. There are lots of ways to manage farms in general with precision ag. For example, plant growth, there are many sensors, for example, soil sensors, which can measure soil content, as well as crops and livestock growth. Seed and fertilizer application can also be managed by sensors, for example, satellites and GIS or other sensing technologies, which can tell you where it is effective to put fertilizer and other seeds or pesticides, as well as irrigation systems, which can be easily accessed and changed to fit soil's needs.
Automated machines and AI. Many machines, including drones, irrigation systems, tilling equipment, and more, have been upgraded by AI or artificial intelligence. These improved machines are much more accurate, precise, and efficient, which in result decreases the manual labor performed by the farmer as well as boosting production. Some tractors, for example, John Deere, are connected to satellites and other aero technology. This technology senses and collects data from the land. This is used for field mapping.
The one key benefit of precision agriculture is a reduction in pollution, which is caused by the improper use of fertilizers and pesticides. So with precision agriculture, we're able to use localized variations of chemical applications and be really precise about the soil that we're actually putting these chemicals onto. Precision agriculture dramatically reduces the manual labor as well through the use of automated machinery and remote farm management, and optimizes soil use, which increases overall productivity and reduces the physical strain on farmers. In essence, precision agriculture stands out as an environmentally friendly farming approach that ensures resource optimization, minimizes pollution, and enhances overall productivity for a sustainable agricultural practice with far-reaching positive impacts. So the AEM, or the Association of the Equipment Manufacturers study of the environmental benefits of precision agriculture, examined the impact of various technologies and productions of row crops, broad acre crops, roots and tubers, as well as forage. And the data overwhelmingly shows that precision agriculture can have positive effects on the environment in all of these areas. So the study showed that farmers consistently using various precision agriculture techniques achieved a 4% increase in crop production, a 7% increase in fertilizer, a 9% reduction in herbicide and pesticide use, and a 6% reduction in fossil fuel. While these seem like small numbers, this equates to 2 million acres of cropland avoided due to more efficient use of existing land, 30 million fewer pounds of herbicide, 100 million fewer gallons of fossil fuel, and enough water saved to fill 100,000 Olympic-sized swimming pools.
Our game prototype is a farming simulator which uses precision agriculture methods to inform and to educate people of what precision agriculture is and how it is beneficial.
When you first start playing our game, you'll run through the instructions and goal, which are to plant, harvest, and produce, as well as making as big a profit as you can. You can see there's a dashboard area, which will display the cost of equipment, show you the values of production, as well as your profit. There's also a store where you can upgrade or buy new machines, as well as average materials. One of the things we learned about in our academy was how and what is effective and sustainable. During our research, we learned that many precision ag technologies can be connected to your phone. We decided to implement this into our game. For example, if your crops are dry, they won't grow. As farmers have to take care and manage a lot of things, they may not realize this problem. However, the game demonstrates how you can get an alert on your phone from a soil sensor. From your phone, you can also adjust the irrigation system to match the plant's needs.
All right, and that is the end of our presentation.
Thank you, guys. All of the games we've seen so far are pretty neat, and I would love to be able to play one of them sometime if they ever do come out in some sort of prototype. One of your slides focused on artificial intelligence. I'm wondering what role you all think artificial intelligence will continue to play in agriculture.
I think it's one of those things, and I think my whole group has kind of discussed this at length actually in our preparation for this, but we think that it's one of those things that is going to be very slowly implemented into mainstream agriculture, but right now it is having some really promising results in the testing and planning phases in university campuses. And so we're hopeful and we would like to see that kind of precision used widespread at some point in the future, but we're definitely wary about the cost benefit analysis of that overall.